Introduction to complex numbers. If this is the first time you are hearing complex numbers, then every number you knew is called a real number. You knew numbers like 0, 1, 2, 3, and so on in your earliest childhood. I like to call them, these are whole numbers, but I like to call them kindergarten numbers. You knew as a kindergartner, and you use these numbers to count objects. So you counted, for example, number of people in the room. You started to count and you went 1, 2, 3, and so on. And if there is no one, then you said there are 0. At that point, negative numbers did not make much sense to you because negative numbers cannot be used for counting. So these were the first numbers, and then later on, you realize that negative numbers are needed to explain concepts like temperatures lower than or colder than 0 degrees Celsius, for example, or if you want to explain the height below, or if you want to explain the depth of a lake or river or something like that, or swimming pool, or if you want to talk about your bank balance being negative or something like that. So negative numbers were introduced later on. So what we did is we added to this list 0, 1, 2, 3, and so on. -1, -2, and so on. Now all of these numbers are called integers. So first set was this, then came integers, and then you realize that even these numbers are not enough, because if you have one cookie and if there are 2 kids, and if you want to use a number to describe how much each kid gets, then you came across numbers like half or 3/4, something like that. Now all of these numbers, these are called rational numbers because they can be written as a ratio of integers. And then we needed some more numbers. Not all numbers are rational. So all integers are rationals, but rationals are little more than that. But not all numbers are rational. For example, square root 2, you cannot write as a fraction of 2 integers. Now, a very popular number that cannot be written as a fraction is pi. So numbers like these are called irrationals. So every number that you knew, whether rational or irrational, is called real number, and they all are represented as a point on the real number line. And we generally drop the word real, we just call number line. We write 0 somewhere in the middle, then positives go to the right, then negatives go to the left. And we typically only write integers when we are writing number line, but every real number is here on this number line. So for example, half is in between 0 and 1, right in the middle. 3/4 is closer to 1. And pi is about 3.14. So it's more than 3, but less than 4. It stays close to 3. So these are all real numbers. Now, as it turns out that, again, real numbers are not enough to explain more concepts. For example, if you want to solve this equation, x square equal to -1. Now, you cannot solve with any real number because every real number, when you square, it's going to become positive. For example, look, 3 square is 9, but -3 square, this is also equal to 9, because when you square -3, you're multiplying -3 times -3. Negative times negative is positive. So that's why this becomes 9. So this cannot be solved if you have only real numbers. So what we do is we come up with something called square root of -1 and we call it I. So I is square root of -1. It's not a real number. We call it an imaginary number. So this is the definition of the number I, and it has this property. If you square both sides, you can see that I square is equal to -1. So now you can solve an equation like this. X square is equal to -1, and we know that I has to be a solution to this. So we have expanded our number system to include solutions to equations like that, and now we call this as imaginary number, and real number and imaginary numbers together are called complex numbers. Now this is not an invention just for the sake of mathematics, just to increase the number system, but they're extremely important in physics, electrical engineering, and a lot of other disciplines. So we will learn about this complex number system. Now, going back to our number line, this was our real numbers: 0, 1, 2, 3, and so on. So all of our numbers were along this line. But now what we do is we draw a perpendicular line at 0. And our number system has now become two-dimensional. And this is the old real number line is called real axis. And you remember the number I, square root of -1, we plot it here up on the vertical axis. So on the vertical axis, the numbers go I, 2i, 3i, and so on. And then down on the vertical line, you have -I, -2i, -3i, and so on. So this axis is called imaginary axis. So all of a sudden, when we introduce that I, then our numbers have gone from being one-dimensional to two-dimensional. Now every point, earlier we said every point on this number line represents a number. So this point represents pi. This point represents half. Now every point on this plane represents a complex number. So for example, this point, so let me look at the intersection of these two lines. So this point is at a distance of 3 to the right and 2 up. So I'm going to say that this point has a real part of 3 and an imaginary part of 2. So this number is 3 plus 2i. So every point will look something like this. For example, this point is going to be, the real part is -2 and the imaginary part is 1. So you can write this as -2 plus I. And let's look at this point, which is at the intersection of these two lines. So this one has a real part of -3 and an imaginary part of -4. So this is -3 minus 4i. And this point here has a real part of 2 and an imaginary part of negative 3. So this number is written as 2 minus 3i. Now every point on the real axis will just be our old number. So this point is 2. What about any point on the imaginary axis? This is going to be 3i. So its real part is going to be 0. So you only have one term, 3i. This point is negative 4i. But if it is not on the axis, then it's going to have two components. You have a real part and an imaginary part. So every complex number appears in this form, a plus bi, where a and b are real numbers. So a is called the real part and b is called the imaginary part. And since you're multiplying by I, that's what you have an I associated with ba. So that's why b is called the imaginary part. And so this is what a complex number looks like. A complex number is any number in this two-dimensional plane where the horizontal is called the real axis, the old number line, and the vertical axis is called the imaginary axis. And every point in the plane will have two components. And some points, like any point on the real axis, will have only one component, but you can say that it has a zero imaginary component. So that's all I have in this video. There is, since it was just an introduction to complex numbers, there are no exercises for this. But in subsequent videos, we'll talk about doing arithmetic with the complex numbers. So we'll talk about adding, subtracting, multiplying, and dividing complex numbers. And until then, have a great day, and I'll see you in the next video. Thank you.